we go. I hope it doesn't cut out again. This is ridiculous. I don't know what to do. Anyhow, this Zoom session, I hope it stays, will has been brought to you by the Fractal Round Hex Quilt F. We proceed. So, okay. What the hell is going on here? Modules, excuse me. Strange. Okay. 6.1. Right. Right. Greatest common factor and factoring by grouping. A greatest common factor is when you have two numbers, and the greatest common factor is the biggest number that divides into both of them. This is different from the least common multiple, which is the smallest number that they both divide into. Now, people get confused. When they think greatest common factor, they think this bigger number. No, it's a common factor, so it's beneath both of them. But it's the biggest one in this case, between 4 and 6, it's 2. And least common multiple is the smallest number that's the multiple of both. Like I say, people get these confused. All right. All right, so for example, 4 is 2 to the second times 3 to the 0. 6 is 2 to the first times 3 to the first. The least common multiple is 12, which is 2 to the second times 3 to the first. So of these two powers, 2 squared and 2 to the first, use 2 squared. Of these two powers, 3 to the 0 and 3 to the 1, use the bigger one, 3 to the first. Greatest common factor uses the smaller of the two powers. 1 and 2 for 2 uses a 1. 0 and 1 for 3 uses a 0. So LCM is primes to the bigger powers, GCF is primes to the lesser powers. For example, here's 18 and 60. 18 is 2 to the 1, 3 to the 2, 5 to the 0. 60 is 2 to the 2, 3 to the 1, 5 to the first. All right, now the LCM uses the bigger of the two powers. Here's 1 and 2, so 2 to the second. Here's 2 and 1, 3 to the second, 0 and 1, 5 to the 1. This multiplies out to 180. Which both 18 and 60 divide into, and into no smaller number. Here, if we use 2 to the 1 and 2 using the smaller power, 1, 3 to the 2, 3 to the 1, smaller power 1, 5 to the 0, 5 to the 1, smaller power 0. That gives us 2 to the 1 times 3 to the 1 times 1 is 6. There's another method for finding GCFs called the Euclidean algorithm. It's available as a tutorial and a problem set in the extra credit section of this course in the module. All right, I mentioned that. Now, you can also find greatest common factor and least common multiple for algebraic terms. GCF has the GCF of the coefficients times variables to the lesser powers. LCM is LCM of coefficients times variables to greater powers. So for example, here's 18, 18x to the 5th, y to the 4th, 60, x to the 2nd, y to the 7th. 18 and 60 has a LCM of 180. 5 and 2, we put a 5 here. 4 and 7, we put a 7 here. Greatest common factor, which is what we'll really be using in this section. 18 and 60 has a greatest common factor of 60. 5 to 2, x to 5, x to 2, we put a 2 here. Y to the 4, y to the 7th, put y to the 4 here. So this is the greatest common factor. Or here's three terms. Greatest common factor of 24 r cubed s to the 5th, 36 r to the 8th s to the 4th, and 48 r to the 4th s to the 4th. Okay, 24, 36, and 48. 12 goes into all of them, and no greater number does, so they put a 12 there. R3, R8, R4, 3 is the least power, R to the 3rd. S to 5, S to 4, S to 4, 4 is the least power, so S to the 4th. So 12, R to the 3rd, S to the 4th. Thank you for your patience during this interruption of service. All right, now you can, we factor an algebraic expression by removing a common factor. Oh, by the way, later on we'll see that the reason why we're factoring algebraic expressions is in order to solve equations due to something called the zero factors rule. If you have expression equals 0 and you can factor this expression, then one of the two factors must be 0. We'll get to that later. So if we have a bunch of terms all with a common factor of x, we can remove it and put in parentheses what remains. Now this is a complete factorization if x is the greatest common factor of all terms. If there's still any common factors between these, it's not a complete factorization. So here's 24x plus 16. 24 and 16 have a common factor of 8. Out it comes. And divide these two terms by 8. You get 8 times 3x plus 2. Here's 45a squared minus 9a. Common factor of a, common factor of 9. Pull that out. 9a times 45a squared over 9a is 5a. Minus 9a over 9a is minus 1. So 9a times 5a minus 1. Here is 15x squared y minus 10x squared y squared. Well, 15 and 10 have a common factor of 5. We have x squared common factor, y and y squared, pull out a y common factor. We're left with 5x squared y, and dividing these two terms by that, you get times 3 minus 2y. Here's 14r plus 15. Well, there is no common factor. So it just is what it is. And so this is called a prime polynomial, like a prime number. All right. Now here is a relatively specialized method called factoring by grouping, or I call it unfoil because it does foil backwards. ax plus bx plus ay plus by. These two terms I can group and have a common factor of x times an a plus b. These two terms, if we group them, they have a common factor of y times a plus b. Now these, well, a plus b is a common factor, so we pull it out here, leaving that, times x plus y. Now if you write it backwards, that's FOIL, first, outer, inner, last. So this is it's the reverse of FOIL. So for example, ax plus 8x plus ay plus 8y. All right, these two terms have a common factor of x times an 8 plus 8. These two terms have a common factor of y times 8 plus 8. Pull out an a plus 8 times x plus y, and there you are. Oh, sorry. All right, here we go. A bunch of examples. Minus 24x to the fourth minus 48x to the third plus 36x squared. Well, 24 and 48 and 36 have a common factor of 12. And we'll pull out a negative 12. X to the 4, 3, 2, lowest power is 2. So we pull out a negative 12x squared. That divided into each of these terms leaves 2x squared plus 4x minus 3. So there. Minus 4a cubed b squared plus 14a squared b squared minus 10ab squared. 4, 14, and 10 have a common factor of 2. And in this case, we'll pull out a negative 2 just for it's negatives here or it's in here. A cubed, a squared, a, common factor of a. B squared, and b squared, common factor of b squared. So we pull out a minus 2ab squared. This divided into these three terms leaves you 2a squared minus 7a plus 5. So here's the factorization. Now here's one people often do in reverse. And when they see this in the book, what they do is they distribute yx plus 2y plus 3x plus 6. That's the exact reverse direction. They want to factor this. And here's a common factor of x plus 2. And it's times y plus 3 here. Y plus 3 times x plus 2. Now this one, we'll unfoil it. 5x cubed minus x squared plus 10x minus 2. These two terms, 5x cubed minus x squared, have a common factor of, oh dear, these two have a common, no, oh dear, something's gone terribly wrong. Oh my goodness. I think this one is erroneous. I'll have to take another look at it. I think we might have to make it an x times 5x minus 1, and then here's a 2 times 5x. You know what? This one is completely wrong. Honk. I'm gonna have to redo this in the Canvas notes. So this is 6-1, 6 number 83. Redo. That was erroneous. So okay, then we're gonna have to redo this. Here's 2ax plus 2bx minus 3a minus 3b. Okay, there's a 2x in common here. Pull out and leave an a plus b. There's a minus 3 in common here. Pull it out, leaves a plus b. And here's an a plus b in common times 2x minus 3. There's that. I am so sorry. This should be entirely different. Like I say, I'll fix it in post. (22a cubed minus 33a squared). Well, 22 and 33 have a common factor of a. A cubed, a squared, lower power is 2, so we pull out an a squared. 11a squared. 22a squared cubed over 11a squared is 2a. 33a squared over 11a squared is minus 3. So 11a squared times 2a minus 3. Yes, kitty. I'm having a cat meowing at me. She wants treats, so I'm going to throw it out the door and she'll follow. Excuse me. I was keeping that door open because I wanted some circulation, but fortunately it's getting cool. It should be getting cooler now. Where were we? Okay, right. So common factor of x here and here, x times a plus b. Common factor of minus 1 here times a plus b. Remove a common factor of a plus b times x minus 1 here. 6x squared minus 2xy minus 15x plus 5y. All right, now 6x squared minus 2xy, common factor of 2x. Remove 2x from this and this, we're left with 3x minus y. We pull out a common factor of minus 5. Again, we'll have a 3x minus y. So remove the 3x minus y here times 2x minus 5 here. Here's just a simple factorization one. 12 uvw cubed minus 15 uv squared w squared. All right, 12 and 54 have a common factor of 6. U to the first u, out it comes here. V and v squared, v to the first here. V to the third and v squared, w to the third and w squared. Pull out the lower power, w squared. So 6 uvw squared. When you divide these two terms by this, we're left with 2w minus 9v. 6 uvw squared times 2w minus 9v. Okay, that's it for this. Stop the recording for this.